Okay, so for this experiment, you're gonna have to use some type of stopwatch or a ruler to measure either time or and distance, because you're gonna need both of those to measure the kinematics of how it's moving, right? So to start, we'll draw. So we're gonna have a free body diagram. In a free body diagram, usually you'll draw a square, and you'll draw forces coming from that square. And so I've done that here already. So what you have here is your object, right? You have whatever it is. So you represent it as a square, and you're gonna apply a force to the right? And this is the force, and that force is the equation for force is F equals ma, mass times acceleration. And because now you've added a force, that object is going to be moving, right? And once that object moves, now friction is going to hold it back, right? So the force of friction is going to be in the opposite direction of the force that you've added, right? So this is the force of friction to the left. As you're pushing the object to the right, force of friction is pulling it to the left, right? And the equation for force of friction is mu times n, and the mu is the coefficient of friction, and the n is the normal force. So the normal force is this force that whenever an object is resting on a plane, the normal force is facing in the opposite direction of gravity, right? So for example, I'm gonna, let me see. So I'm gonna draw it in red. So this is the force of gravity here, right? Let's assume this is a straight line. That's the force of gravity. So because gravity is pointing straight down, the normal force is going to be equal to the force of gravity, right here, in the opposite direction, right? So the blue one is your normal force, okay? And that should get you started. And then now, once you find your time and your distance, then you can plug it in to find the coefficient of friction, which is this. You're looking for the coefficient of friction here, right? So what you need to solve for is you need to solve for this right here. You need to solve for the acceleration, right? And how do you solve for acceleration? Acceleration is equal to acceleration is equal to velocity divided by time, correct? Right? And then, so how do you find the velocity? Velocity is equal to distance divided by time. In other words, so if I were to combine these equations, acceleration is equal to distance. This is usually represented by an x. Distance divided by times squared, right? So now you can use, the distance and the time that you've calculated to find this a, and then plug that in here. Okay. And once you set these two forces equal to each other, then all you'll have to solve for, because this m will cancel out, right? And you already know what g is. It's negative 9.8, right? Because this is mg. That's an m. That's a g. So now once you set them equal to each other, you'll find that the m's cancel out, and now you'll just have mu, and then that's all you have to do. Thank you. I hope that helped.